Milyen Péter, nem mondta? The Hungarian title was similar. It's an exceptional case, not a method that can be used all the time and everywhere. It is actually a case study that I'm going to show to you in the presentation. In 2007 and in 2009, when I was a speaker of the respective activities, whenever I chose my topic, I always wanted to give you a comprehensive picture. And I wanted to cast some light on all the tiniest detail. This year will be different. I won't give you a very exhaustive explanation. I'd like this presentation to be interesting, to have some morals, and to give food to thoughts. There is always a question which determines or specifies which topic to choose. For a couple of years, I've been interested in IT security expert engineers' work. When they work out and install network security solutions and designing and configuration and installing such systems, testing such systems, documenting such systems, maintaining and operating such systems and supporting the operation of such systems. So whoever works for this kind of jobs, would this person encounter cases where special skills and abilities are needed and to be applied? I'm not, I don't want to know if it is necessary. It's absolutely obvious that an IT engineer should have knowledge about malicious code and attacks. He must have a basic knowledge about attack types and the operation of attacks. But what I'm interested in is that this kind of knowledge and skills that he has gained are used during his work. Will he have to use them? Maybe he will never ever have the necessity to use them, but sometimes the answer is a straight yes. And my intention is to show you the case study when they are really forced to use such things. And in 3 different parts of my presentation, I will ask 3 questions, and those who know the answers of all 3 questions will receive a Belgian beer from me. So all 3. I will sponsor this Belgian beer. It is a company case study that buys licenses to encrypt hard disks. It is the encryption of full disk data sets, all the data on the disk. He needs it because there are some VIP users of the company who have portable computers with their own ports, and they store confidential data and they carry them everywhere. So if this notebook disappears or if it gets stolen, then this person may get data that are very sensitive to the company. So actually it would be a leak. It doesn't mean that they buy the software and install it right away and put it into operation, but they use some caution and they use a pilot system beforehand. There is a management system which is going to be configured, and after the configuration in the central management part, you can produce the installing component, which will be encrypted on the notebooks for the hard disks. In the pilot, they've chosen a person, a VIP IT persons, and they encrypted. A couple of weeks elapsed, and this person sees that after a reboot, the notebook will not get to the usual phase, but will just rebounds an error message indicating that the encrypting client application is not installed on the computer, and he's quite sure that it cannot be the case because they really installed it, so it is an unusual event and also a discomforting effect because there is only one reboot button and then starts the whole process again. And since you know that his data are encrypted on the computer, so he will be a bit, he will worry a bit about the encrypted data he has on the computer and how he can have access to the encrypted data. Let us just build up such an IT security expert advisor who tries to solve this problem for this man. He has some basic skills. He have general cryptography knowledge, learns and reads it. He knows what symmetric encryption means. He knows what AES algorithm means, and he can draw the conclusion that he needs to have a secret key to make a rescue successfully. If it was encrypted symmetrically, then he needs a secret key. This person doesn't only have general cryptographic knowledge, he also has some product-specific knowledge. He has theoretical knowledge. For example, he knows that the data are encrypted to such an extent that they are always in such a form, and whenever there is a need for a program to run in memory and have access to this data, then they will be disencrypted in an on-the-fly way. He knows the structure of the program. He knows that it is not a simple client, but there is a manager with its own database, and configuration data are stored, and secret keys are stored in this database, and also there is a synchronization process which gives the encryption key to the client. Then he will get it from the central database and sends it to the client. And he has some practice in installing such a software, configuring such a software, and he knows that on the normal operation, the client computer boots a kind of pre-authentication interface, which is absolutely independent of the operating system installed on the machine. On this interface, we should give the proper username and password, and only then can the operating system be loaded. Let's take a further step. So he doesn't only know about the products and installing the products, he should have operating experience. For example, operational experience. He can handle normal operational events, that the person forgets his password and cannot enter this pre-authentication surface or interface. He sometimes closes his user drawer, and he knows how recovery option can be used in the software and how the password can be resetted, or a kind of closure, how can be disabled or re-enabled. He has also experience which problems that have already been documented. For example, a virus infection of the given computer, and the hash application should never allow the operating system to boot in the safe mode. They don't want to connect the computer onto a network because then infection may spread. And the simplest thing is to remove the virus. That first encryption should be opened, and then in a safe code it can be booted in. If the operating system is loading file is injured, then the operating system cannot be loaded. again encryption must be removed, and the non-encrypted content can be accessed. An engineer could restore the operating system, but at least he can save data, backup and restore data. And there are also some unusual things which are never talked about, how the situation can be handled. Those who support operation, or who is responsible for operating a system can encounter a case when the software was installed on the notebook and the whole encryption process started, and all of a sudden, with a sudden move, either it was a power failure or a violent switch off, so the computer was switched off. During normal switch off there is no problem, because these software are prepared, are written in such a way that they have a log how far the disk is encrypted, and after a reboot they use this point to go on with the encryption. Although certain sectors have been surely encrypted by the software, if we take a look at the record in the file system, this record shows that the whole disk is absolutely unencrypted. If we have a system which handles the sectors sequentially, they are encrypted to a point, but we don't know how far, and the data save must be made of these encrypted and non-encrypted parts. Please try to consider this problem, and afterwards, after the presentation, we can really discuss this. And there is a second case, a concrete case. Not only the computer doesn't get to the point of loading the operating system, not even the pre-authentication interface appears, only an error message gets in, and we somehow must decrypt the situation. Let's see what kind of initial trials there are. Technically, we cannot really make backup the encrypted data. We need the encrypted data and save it. We have some theoretical knowledge, product-specific theoretical knowledge. If a client cannot boot from a hard disk, then the vendor supports us in two ways. There is also an emergency disk to either it's a floppy, or in older version it was only supported, or it can be a CD in the new versions. The system puts a free DOS on the floppy, and it is also possible to do the booting CD. And then all the exe files can be copied by the means of which special functions can be executed after booting in. In the concrete case, we used the floppy solution to a USB port. In order to use these special functions, there are two obstacles after booting. First is the authorization obstacle, because the vendor doesn't want anybody to use these functions, because these are expert functions. And with these functions, they can really kill all the data on the hard disk. And for this reason, I invented the following thing. For each and every day, for each and every date, a 4-digit number is generated. And if somebody has taken the proper course and indicates the problem, then he will give the four-digit code to the person with which he can authorize himself. Those who participated during the training for this product have certain experience with it, and also received this 4-digit code during the course. And it has the advantage, if he runs into such a program, then the actual date and knowing the actual date and the code, he can also enter at a later point. there is no mathematics behind it. You can really find out how it works. As soon as we went over to authorization, then authentication is the next phase. Authentication is needed in order to get access to the encryption parameters. There are two ways of authentication. There is a local authentication and the central one. Local means that it is on the basis of data stored on the hard disk. Central means that it's in the configuration file of the central database, and through this we can authenticate the system. Our first attempt is always local authentication, but should there be any failure or error on the hard disk, and this was indicated by the error message as well, then even there is a high chance that even the local authentication won't work. We have one opportunity less, but there is one opportunity left. The top administrator should log on the management interface, and with simple clicking, the configuration of this notebook can be saved to a client file, and then it can be booted in, and then we can authenticate it. The local IT staff, the staff of the member of the local IT who noted down a wrong password, found a password which was unoperational. The second problem is that external IT security consultant had no notes about the passwords of the pilot system. He had ideas, but they were wrong tips. The software doesn't let us have more than 10 tips. And if we have had all the 10 tips, then here there is a total closure block. It's a very inconvenient situation, and we feel very uneasy in such a situation. And I would say that many of you would say that this is where I stand up and quit. This data cannot be saved. Install it again and try to get it from someplace else. But those who have some bites of conscience tries to do some desperate things in a certain situation in order to save his face. For example, what would happen if we asked the vendor that we know that there are two authentication methods, but he may have something else that was built into the software. Will this bus take me to New York? Maybe the question doesn't seem to be a very rational type of idea. What can we do in such a case? And the answer comes back, and the answer wasn't positive. They couldn't give us any idea to solve the situation. It was a kind of poetic question. They said that if they had such a method, they would share it with us. Still, we had some time to move ahead and try to find some solution with a minimum chance. We may have some luck, and during the synchronization process, the encryption key didn't get down to the client disk, but it was not properly encrypted. This hard disk should be connected to another notebook, and it will be booted from his own disk. A colleague of us did this, and that was an unexpected result. On the other notebook, the antivirus application started to scream that he found malware on the master boot record of this notebook, malicious code. And in this situation, it was a great joy for us. and a very lucky thing for us, because some memories came up from the DOS era, when viruses went into the boot record, and who had experiences with such programs and remember certain parts of slides from previous presentations, they probably have a certain idea about the solutions of this to this program. Let's just build on this security expert further. He has some practice in reverse engineering. Let's assume this kind of redebugging, reassembling. Reverse engineering is one of the most important hacking capability. That's my personal opinion. That's the most important property of a hacker. He should have practice in reverse engineering. Reverse engineering is extremely useful for anybody to understand the exact operation of an application at a deeper level, as it is discussed in its documentation, and the application is not over complex. But there are people who can really use this for very complex application, and all tiny details can be revealed from the exact operation of the application. I read some license agreements in which reverse engineering, the use of reverse engineering is absolutely forbidden on the given legal program, but malicious programs quite rarely come with EU law. So let's speak about the master boot record. At the beginning there is an executable program code, and at the end there is a partition table, a kind of data section, 4 times 16 bytes, with which we can produce the first 4 primary partition. During booting, BIOS loads the master boot record content into the memory with segmented address to address 000 offset 7, and then control is given to this code. It is important to mention that since the CPU operates in real mode in this phase, the machine code is executable on 16 bits, even if a 32 bits operating system is installed on the computer. It can use 32 bits register, but different operation code is needed for this. The code for this master boot record has the primary task to find the active partition on the basis of the partition table, and to load the boot sector, and the control IP control is given to this. That's a typical Windows master boot record in Hexa. Of course, it is not digestible, so let me just show you some assembler code. I don't want to go into details with the XOR and move instruction, push-pop instruction. It is not so exciting what happens from instruction line to instructions line, but the code looks like this in assembly. At the beginning, there is a memory copy routine with the moves. Because the master boot record is in the 7C00 offset in the memory, but later on the code of the active partition will be stored here, and this code will overwrite itself, and it is not very fortunate. So as a first step, the relevant part of the MBR code is copied to another address of memory. If the MBR code is over this step, then on the basis of the partition table, we must search the active partition. This 4 times 16 bytes record the first byte always means the status of partition. If it's 0, then this partition is inactive. If it's 808182, which is a signed number, a negative number on the first byte, then 80 is the first one on the first hard disk, 81 refers to the second disk, and so on. This code tries all 4 records. It's not enough to find an active partition for the first attempt, but he will look through the 16 as to the whole table and checks if there are any active partitions. If 3 partitions are inactive and 1 partition is active, that's the desirable case, a good case. If all 4 partitions are inactive, then a persecutor report message appears on the screen. If there are other errors, then an invalid partition table error message comes up, and the machine gets into an infinite loop. The processor gets into an infinite loop. And if we take a further step and we found the active partition, then we should check the location of it on the hard disk. In the case of small size hard disks under 8 gigabytes, that's what I mean by it, there are no real problem. BIOS have a traditional read operation which specifies the sector on the basis of CHS, cylinder head, and S sector. CHS, cylinder head sector. So it's not an absolute number which specifies the sectors, but gives the cylinder, the head, and the sector. CHS limits us to the 8 gigabyte size. If we have a bigger disk, and if the boot sector is above 8 gigabytes, then with this traditional read operation, we cannot access this, address this sector. So then the control must be performed where the boot sector of the active partition falls. If it's under 8 giga, then we don't need LBA support. We can use the standard 02 function code, where with the traditional read operation, if there is LBA support, then we have a 4.2 code read operation which should be used instead. It doesn't matter for us which one happens, but it will read the code sector of the active partition on the basis of the entries of the partition table. But there is also an interesting thing here. Should the reading operation fail, then there is a typical error message, error routing operating system, but there is one exception from the rule, and this is the FAT32 Windows 95 FAT3 partition. In this case, the active partition, we check the type of the active partition, and the system will try another attempt. You can see three instructions in the blue part added ADC. With these 3 instructions, it moves forward 6 sectors from the present sector and reads the sector 6 sectors after the given sector. My first question, which goes for Beer, what is the task of this code? What can we achieve if we don't read the active sector of the partition, but a code pointing at a sector 6 bytes down the line, on the 6 sectors down the line? You may think it over. Why does it read, instead of the active sector, the 6th sector behind it? And if we were successful in reading in the boot sector, then the system checks the last 2 bytes. Every boot record has a traditional ending, AA55, 55AA, and this is the end. And if this is the end, then no missing operating message appears, and then the active partition's boot sector is loaded, and only control must be given to it, and this is the task of the MBR code.
Lépjünk tovább. Volt szó visszafej.
Let's move on. We mentioned reverse engineering, and we can connect the two things. We're talking about MBR reverse engineering. I'm usually interested in reverse engineering malicious code. On a personal note, people who reverse engineer codes started out somewhere. I began back in 1994. The reason was I bought a hard disk for my computer, which was passed on to me with a feature, a hardware test program. And what they didn't know, and wouldn't tell me obviously, they didn't know that the hardware tester was infected by a virus. I realized that in a week. A neighbor borrowed from me a Minesweeper program, and I began checking the hard disk. I also checked the floppy diskette, and I found a 22 kilobyte program. It was infected by the back from 2000 virus, and there are various options. Either you borrow an antivirus program from someone, or I could have run back to the service station and ask for an exchange. What I did was I printed the screen image of the code, and I began to reverse engineer it. If you've never done that, 2000 bytes took me 2 days at the time. That was the content. Coming back to this company notebook, the master boot record had this content. I displayed it hexadecimally because the content you see up in the slide, I inserted that into a file, and then I made the file the input of an application. And my question is, what is the application that was popular under DOS, and it is still there for Windows XP, which will accept this as an input file with this content? That's the second question, for a beer as a prize. So let's analyze this jointly. This is the disassembled code. I'm not going to display each line and explain what goes on in them. I will just highlight the key features. Last year's presentation touched upon Intel assembly, and I hope you saw that presentation and you recall how it works. And here you find the important stuff. Subtract SUV, sub, and I put a comment next to it. It reduces the RAM top size by 2 kilobytes. Now, what's RAM top? It goes back to the DOS period, when Bill Gates allegedly said that 640 kilobytes must be sufficient for everything. And this 640 kilobytes was dubbed conventional memory. The RAM top indicates this 640 kilobytes hexadecimally. It can be described like this, and the hexadecimal value should be stored in the comment. 0413, that is. And most DOS viruses, the memory resident viruses, which don't just run on one occasion, they become resident in the memory, waiting for their next kill. And what they did was they reduced the size of the RAM top. And the new RAM top value above it, but below the 640, they would copy their own code. And that's important because one of the DOS interrupts is about checking this memory area and enables the DOS-based programs to run their memory allocation, which is a way of protecting their own code. We see a 2 kilobyte reduction in size, so that means the malicious code will be maximum 2 kilobytes in size. Now this malware also contains a memory copy routine at the very beginning, and it does the following. First of all, it reads the 512 bytes in the master boot sector and copies it into the new RAM area, and another two sectors whose addressing is as follows: 3D hexadecimal 48 plus 13, that's about 61, so it's sector 61 and sector 62. The contents are copied consecutively, so 1.5 kilobytes worth of information is copied. And this consists of the master boot record and two other sectors. Continuing to look at the sector, there's a XOR operation dumping the register and code-neutral operations, and then four important lines follow. The first of these is the interrupt vector table. 1.3 is the interrupt vector. That's the BIOS disk manager, including all the operations. The original address is copied into a vector register, and two lines further down, the register content is written into the code, and it will divert the 1.3 interrupt code by giving it a new offset 006A address and a new segment address that's RAM top in this case. And then it will hand over, in the last three lines, it will hand over control with tricks in the operations to the code saved in the RAM top. I will also show you another important feature, but I'm not going to give you a step-by-step analysis of how this malware operates. And this one is about another sector read step, which is 3F hexadecimal 63. Sector 63 is whose content is read into the memory, and an already known 7C00 offset address is used to store that new content. Just as a reminder, that's where we've loaded the MBR code, not the infected code, but the normal code. And then a jump instruction can be seen here, and our malicious code will hand over control to that memory address. The third question is, let me add to this, what may have been the sector's content in position 63? But I'll answer my question. That's the pre-infection master boot record content. So the third question deals with the events and their significance from the MBR point of view. So when the encryption client was installed, what could have taken place, and what may have happened when the MBR infection occurred. So what could have been the sequence of events? That's the third question. Now, what is the solution to the problem? We've strayed away from the original problem, but something was wrong with the hard disk, and that's why we got these error messages. And we see the problem now in the master boot record. We don't have the encrypted applications boot record, not even the original Windows installed master boot record content is what we see, but we're looking at a malicious code. What do? We do a very simple operation. It's a lot easier and simpler than most restore operations. What we do is the contents of sector 63 will have to simply be copied back into sector 0 to replace the master boot record that is in there and reboot. This simple operation resolved the issue, and from then on everything was working all right. Thank you very much for your interest and attention, and I wonder how we're doing in time, but if you have any questions, I'll be happy to answer. And those who know the answer to the three questions, please come up to the rostrum and we'll discuss the answers.